All right, here's a little warm-up problem for you guys. Hopefully you've been working on it. I'm gonna walk through it and try to have a warm-up problem for you guys by 8 a.m. up, maybe even earlier every morning that we have class. So if you get here early, you got something to refresh your brain on. I know it's been a while and we're going through it kind of fast. So here we got a product. I'm gonna call this smiley face and this frowny face, because I see down here, I got smiley face and frowny face again. So maybe I'll only take the derivative once and not have to do it a bunch of times. So d smiley face dx, I want to take the derivative of this with respect to x. So on the 3x squared, the 2 comes down, multiplies by the 3, and I have 6x. And the power drops by 1. 2 minus 1 goes down to 1, so we don't write it. On 2x, the power is 1, so we bring the power down. 1 times 2 is 2. And the power drops from 1 to 0. X to the 0 is 1, so we don't have any x's left. The 4 goes away. It's a constant, so it doesn't change with respect to x. So that's d smiley face dx. And then d frowny face dx. Make that a little bit bigger. We do the same process. We bring the 2 down, we multiply it by the 7, we get 14. The exponent drops down to 1. And then we come over to the 3x, the exponent is 1, we bring it down. 3 times 1 is still just 3. The exponent drops to 0, and x to the 0 is 1, so we don't have any more x's there, and the 8 goes away. So the product rule was, if you remember, we just take the derivative of them one at a time and multiply, leave the rest unchanged. So if you do them in order, it's easier to keep track of. I just do the first one, derivative of the first one first. So we already did that. We have 6x plus 2 as the derivative of the first one. And it's still multiplied by frowny face. And then we add. This time we leave the first one alone and do the derivative of the second. So multiply b by d frowny face dx, 14x minus 3. There's some algebra shit you can do to clean this up. And you should do it on the test. But I'm not going to do it right now. All right, next one. It has the same setup. We do the product rule basically, but we're going to do subtraction on top, and then we got to divide by the bottom squared. So I could actually just hijack this line. And replace that with a minus right there. And then we want it all over low squared. Low was frowny face. Now this definitely should be cleaned up. So clean up the top. Get it down to a single polynomial. And then ideally see if it factors and cancels anything on bottom. I suspect it's not going to. Yes, Matthew.
Should we expand the bottom to see, like on the test, should we expand the bottom to see if it cancels out on top? Like
if you can cancel it out by expanding the bottom, you should be able to do the same canceling by factoring the top without expanding the bottom.
Okay,
You know what I mean?
no,
Let me show you. Let's say after cleanup, this is gonna be a completely different problem. I'm gonna do something similar. Let's say we have. Let's do. X squared minus X minus 2 is what's left on top. And let's say we have X plus 1 squared here. If I factor the top, I'm going to get X minus 2, X plus 1 over X plus 1 squared. And so it does simplify. The one X plus 1 on top cancels one of the X plus 1s on bottom, and that's what I'm left with.
oh, okay. So the form we left it in on the last page, you should be able to see it.
Yeah,
Oh,
this is what I was going for.
gotcha,
Get the top down to a single thing. We got a couple of parentheses multiplied together, like multiply all that shit out, then do the subtraction, get it all down to a single polynomial. And like if it doesn't have a 7 in front of it or a multiple of 7 in front of it, there's no way you're going to get a 7 here. The only way to get a 7 in front of the X squared is there's got to be a 7 on one of these in the front. And so you should be able, hopefully be able to, with practice, recognize right away when it's going to cancel or not. In this case, though, like your question was, can we multiply out the bottom? If I multiply out the bottom, that doesn't help me any. I see the top and I see the bottom, and that's not gonna, they don't look like they cancel. Excellent question. All right. Any other questions? All right. 2.5. Derivatives of trigonometric functions. How are you doing, Senzi? Squeaking over there. She didn't want to tell me, she just silenced it. Yeah, I harass other people, not just you, Voldemort. I'll have you know, I told my class yesterday about Voldemort. I didn't use your real name though. I saved you that. But I did expose you more. As Voldemort. Because it was funny. All right, so what are our trig functions? We got sine x, we got cosine x, we got tangent x, we got their reciprocals, cosecant x, secant x, and cotangent x. And I guess I should probably put the x in parentheses. Those are our 6 basic trig functions. Oh. Roberto, yes. My internet was down all day yesterday, and it came up at like 5:30 this morning. I'm gonna post it when I get home at lunchtime. He was asking about the recorded lecture for 2.3 and 2.4. There is a recorded lecture though, yes, it will be up. All right, so we're gonna hit each of these with a ddx. Derivative with respect to x. I'm just gonna show you what they are. Just get this straight at the top of your nose. What are the answers to these? because this is what you're gonna look for later, more than likely. The derivative of sine x is cosine x. That's fucking handy. And the derivative of cosine x is negative sine x. Derivative of tangent x is secant squared x. Here's a fun one. Derivative of cosecant is negative cosecant cotangent. And the derivative of secant actually brings itself in secant tangent. And finally, the derivative of cotangent is negative cosecant squared. Those are 6 ones you should memorize. You know what? You will probably have 4 of them remember pretty well, pretty quickly, because for some reason they show up all the fucking time. Sine, cosine, tangent, and secant show up more than cosecant and cotangent. Like I had to glance at my notes for cosecant and cotangent because I don't do them that often. Secant comes up all the time, secant tangent. We are going to derive 3 of these using Matthew's favorite fucking function. What is that, Matthew? What are we going to do?
The f of x one,
That's big. They're all f of x ones.
it's the one with the h.
It's the one with the h. Does anyone need those up longer for your notes? All right. I'm going to derive 3 of them. You should try to derive the other 3 at home. They'll be similar in derivation to what we're doing today. All right, awesome. Let's do it. Let's find derivative of sine x with respect to x. Using our good old limit as h goes to 0 of f of x plus h minus f of x mf, or the power just reset itself. I know y'all can't see it. I gotta wait for it to power all the way off and so that I can power back up. It's loud, isn't it? It's fucking hell loud. And it reset all my fucking zoom and brightness levels. Piece of shit. All right, well, sine x is our f of x. So we're going to have the limit as h approaches 0 of sine of x plus h minus sine of x over h. Any ideas on what I can do from here? Dig into that trig memory of yours. And there's a,
Put 1 over 8 to the side.
that's a good start. I approve of this message. Let's get the 1 over h to the side. That's a good start. That's not going to help us deal with it, but it definitely makes it easier to read and write from now on. Anybody else?
Where,
We could, but it's not gonna help. I like the idea of trying. The problem with squaring it though is that we're introducing change to the answer. We don't want the answer to change in any way, shape, or form. So like when we used to multiply by conjugates, we did it on top and bottom, so it was like multiplying by 1. We never want to change the answer. So if we introduce a square, we got to introduce a square root. But I like where you're headed with it, thinking outside the box. Does anybody remember the sine A plus B formula? Excellent. This gives me a perfect chance to remind you that we over here in our modules, we have the trig definitions and formulas so that you can refresh your memory. Well, scroll down. What am I looking for? There we go, the sum and difference formulas. So what we're doing today is going to use some of these. So the sine one, sine of x plus h, it does sine, cosine, and it keeps the same sign, sine, cosine. And it changes what goes inside. One gets x, one gets h, and then it switches on the next one. Sine of a minus b does the same thing, but it's got a minus in there. We still have minus sine x. And you definitely want to use parentheses here because as a quick little side note, that is something. Sinh and cosh are hyperbolic sine and hyperbolic cosine. Those are actually other forms of trigonometric functions that are god awful. So that's not the same as sine parentheses h. Definitely put parentheses in. Now what can I do?
You can cancel out the sine x.
How?
Or positive.
But I don't have a positive. I have a sine x with a cosine. Maybe I could group them. You want to try to group them? Let's group them.
Could we factor out?
Yeah, that's what I'm going to do. I'm going to factor out the sine x out of these two. So if I factor out the sine x, I have cosine h minus 1. And then I still have plus sine h cosine x. At this point, I'm actually going to move the 1 over h back inside. I could break this up now. Some of these have x's in them, which are not functions of h. They are like sine x is a constant related to this limit of h 0. I can actually take it out. I can write this, or well, let's just do it the long form way. I have limit as h goes to 0 of sine x, and I'm going to put the h with the cosine function. This is going to be multiplied by cosine of h minus 1 over h. And we'll do the same thing over here. We got a limit as h goes to 0 of cosine x times the limit as h goes to 0 of sine h over h. Yes,
Is there a reason you chose to do the H under the cosine? Or
yes,
why? Could you just choose which one you want to do it under?
I can. But if I put it under sine x,
Multiply by each other.
yeah,
Oh,
like this is like 1 times h. I can put a 1 under this one. I get to choose where it ends up. If it was h squared, I could put h squared under one of them or h under each of them. But I chose to keep the h's with themselves, with the trig functions that had h's. Well, this part doesn't change. This is still sine x. Because as h goes to 0, that doesn't do anything. H going to 0 here doesn't do anything. What about these two? Ooh, that's some like, I don't know that it was day one shit, but pretty close. It's been a while. We actually computed both of these. This was 0 and this was 1. We didn't have h in there, we had sine x over x. And we did the limit as x went to 0, but it's the same idea, just a different variable. That was, I don't know, 1.2, 1.3. It's been a while. So d dx of sine x equals, all I have left is cosine x times 1. Yeah,
And so was all of this just to show that the derivative of sine is cosine?
yep.
We need to do all this like the test, like in like a.
I might give you a prove that the derivative of something is something using the limit laws or limit rules. I probably will. I don't know if it'll be a trig function. Oh, but I kind of like where you're going with this. This sounds like a fun idea.
be like a bonus question.
Yeah, that's what we do.
Really? Is that what it should be? But I'm showing you how to do it. I've showed you how to do them all. Like all you have to do is review your notes before you take the test and you'll be ready, right? In theory. All right, I'm betting these two sons of bitches you forgot about. They're easy to forget about. I get it. And generally beyond now, other than proving them in the trig function, we're not going to use them a lot. Later on, we actually have a better, easier way of showing that this equals 0 and this equals 1. It's called L'Hopital's rule, but it's in like chapter 3 or 4. I hope it's chapter 3 because L'Hopital's rule is great. It looks like El Hospital, but the S is fucking silent because they're French. The French like to make some of their constants silent. It's great. All right, you guys ready for cosine x? Are we inspired yet? We'll just go straight with the 1 over. God damn it. Lights out, baby. All right, turn back on, fucker. What goes here in the bracket?
Sin X?
What?
Negative sin X?
That would be the final answer.
Oh,
But if this is f of x, what does the formula give us?
Cosine x plus h minus cosine x.
That's correct. That's what I was going for. Now, I'm betting you don't remember the cosine sum formula. Cosine, when you have the sum formula, it does cosine, cosine. And then it does sine, sine.
Isn't it cosine A and cosine B, and then it goes minus?
Minus the sign switch is
Minus A.
excellent. So instead of A, I'm going to use X. Instead of B, I'm going to use H. And then these are also X and H. So sine uses sine, cosine, and keeps the sign the same. Cosine doubles up, does cosine, cosine, and sine, sine, and it switches the sign in the middle. That's what cosine sum formula does. And we still have minus cosine x. So what are we going to do here? Yep. So it looks like these two are going together. So I'm going to have a cosine x times cosine h minus 1. And then I have a minus sine x sine h. So I grouped these two and I factored out the cosine x. And that went right here. Now what?
the region is order rate.
Put them both over h. Let's put the h inside. We just did this with sine. The process is exactly the same, in fact. So we have limit as h goes to 0 of cosine x times the limit as h goes to 0 of cosine h minus 1 over h. And then we've got a minus limit as h goes to 0 of sine x times the limit as h goes to 0 of sine h over h.
The cosine h minus 1 over h is equal to 0, right?
Right. So this one is 0. And what is this one? What? Cosine x is not a function of h. So that's cosine x times 0 minus sine x is not a function of h. So plugging in h equals 0 does nothing. It leaves it the same. And that's multiplied by 1. And we're ultimately left with the derivative of cosine x with respect to x is negative sine x. I'm off screen because the fucking thing didn't zoom in. God damn it. No one told me I was zoomed in too much. My bad. Yeah,
maybe it's a little late, but. When we plug in 0 for H, for sine. How's that equal 1? Because if the denominator is 0, anything divided by 0 is 0, right?
Right, we are not plugging in H equals 0 here.
Or we weren't.
No, we actually solved this a long time ago. We did, I don't know, how far back was it? 1.3 maybe, 1.2? Let's see. I don't think it was 1.1. Doesn't look like 1.2. Doesn't look like 1.3. It must have probably been under, was it 1.5? Was it under continuity?
1.6.
My bad, I'm scrolling through my notes. We did it, it was in chapter 1. Oh, probably was, because 1.6 was on trig. Yeah, we had limit of, as theta went to 0, sine theta over theta equals 1.
What the least there, right?
Squeeze theorem, yeah. It wasn't a fun proof.
So it's kind of complicated.
It's a complicated proof, but remembering it isn't,
Okay. Gotcha.
right?
Yeah.
I'm still deciding whether it'll be a squeeze theorem on the test or not. A lot of teachers like to fucking throw a squeeze theorem on there, and I don't see the point in it. Unless you're gonna be a math major, squeeze theorem isn't fucking essential to your long-term use of it. So I don't know that it's a productive use of your time. So I'm leaning against using it. Shh, don't tell the other fucking calc teachers. Right? They'll go pew pew on shit on my fucking. You gave a shitty test, you're too easy on them. No, I'm practical. Squeeze theorem. I can count fucking number of times I've used squeeze theorem in all of my mathematics education on both hands. It would take both hands, but that's about as many times as I used it in fucking 6 or 7 years of fucking education in mathematics. It's something you look up and you can't prepare for it. There's like figuring out what to squeeze between is a pain in the ass. The only ones it's really good on is sine and cosine, because the functions are bound between -1 and 1. When you look at the graph of sine and the graph of cosine, y never goes above or outside of 1. Where was I? I was talking about not the squeeze theorem. We were doing derivatives of trigonometry. There we go. That's what we were doing. But that's where it came from, squeeze theorem.
Thank you.
Does anyone need that up longer? All right, tangent. What are we gonna do for tangent?
X plus H minus kind of.
We can definitely do that. The tangent A plus B formula is a pain in the ass to memorize. I think you actually, it's worth a try. You can definitely do this as limit as H goes to 0 of 1 over H. Tangent X plus H minus tangent X. Actually, that might be easier. I was gonna switch to sine and cosine. Problem is, tangent A plus B is one of those I don't remember. I want to say it's tan A, tan B on top of, it's either 1 plus or 1 minus tan A, tan B. Nope, it's tan A plus tan B on top. The minus was correct on bottom. So if we go this route, this is what's going to happen. This switches to tangent of X plus tangent of H over 1 minus tangent X tangent H. And we still have minus tangent x. I don't know if I really like where that's going. Because if I get a common denominator, I need to multiply tangent x by that. And then kind of group them together if I can, but they're not, the tangent x will group together. Yeah, maybe. Maybe. Let's see how it goes. We've got 1 over h. I've got tangent x plus tangent h. This is a formula for that from the trigonometric cheat sheet that's on the modules. I don't have it memorized, so if you have it memorized, more power to you. So I got tangent x plus tangent h. I'm going to take this denominator and multiply it by the tangent x. I'm going to get a common denominator times 1 minus tangent x tangent h. And then that's all over 1 minus tangent x tangent h. I sure hope that goes away somehow, some way, shape, or form. So tan x plus tangent h minus tan x, that helps. Plus tangent squared x tangent h. All over 1 minus tan x tan h. Oh, I think it's going to get there. Well, it should get there. This is a fucking pain in the ass, isn't it? We're gonna do the other one in a second. Let's change colors. Tired of looking at black. Limit as h goes to 0. We've got 1 over h. Notice the tangent x and minus tangent x cancel each other. And I have a tangent x plus tangent squared h. I'm just cleaning up the top real quick to take a look at what I got. Looks like I can factor out a tangent h. And I'm left with 1 plus tangent squared x over 1 minus tangent x tangent h. All right, so this part right here, tangent h is sine h over cosine h. And I have the 1 over h. This is ugly. This is uglier than I wanted. There is one blessing. This thing right here, 1 plus tangent squared is secant squared. So I have secant squared on top over 1 minus tangent x tangent h. And we can split that first part up. I can put the sine h over h together. And then have limit as h goes to 0. Secant squared x over cosine h. Actually, this isn't bad. Times 1 minus tangent x tangent h. Oh, we are getting somewhere. Look at this. We are getting somewhere. Because what's this first part? 1. I have secant squared x on top. I'm going to distribute that cosine h. I've got cosine h there. And tangent h is sine h over cosine h. So when I multiply cosine h times tangent x times tangent h, it should cancel out that cosine h. And I should get minus tangent x sine h. And we're right about where we want to be. Because if we do the limit as h goes to 0, this goes to 1. Cosine of 0 is 1 and sine of 0 is 0. So we're just left with secant squared x over 1, which is secant squared x. That was fucking torturous. There is a much shorter way. But that was the first recommendation I heard, so we went with it. Let's do the shorter way. That was a lot of trig and algebra shit going on in there, right? Clean up. That was like a long refresher for trig and algebra. Are we having fun yet? You guys want to do the easier way? Okay. I'll let everyone finish writing first. I wasn't sure how long that route was going to take. That took a lot of lines. And a lot of different trig functions and shit to remember, formulas to remember. We had to remember the tangent a plus b. We had to remember 1 plus tangent squared was secant squared. We had to remember the sine h over h goes to 1. There was a lot of time spent cleaning up these lines. This is probably the way to go if you're going to use limit as h goes to 0. Your teacher, though, is a cheap bastard. He's sneaky. I have already done the derivative of sine x and derivative of cosine x using limit as h goes to 0. So I'm going to bypass all that and jump straight to doing this as a quotient rule. H prime L minus HL prime over L squared. So d dx of tangent x is I have I prime. I'll write that out without changing what they are yet. And then I've got sine x, and then I'm going to take the derivative of low, which is cosine x. And all of that is over cosine squared x, which is low. Well, derivative of sine x is cosine x. And then we still had a cosine x. And the derivative of cosine x was negative sine x. All over cosine squared x. dx of tangent x is cosine squared x. And then negative sine times negative sine is positive sine squared x. There's two ways to proceed from here. One is definitely shorter than the other. Any ideas? Go.
Make it one, cosine squared x.
So take these two and make a 1?
Yeah.
Okay, that's one way. If we do that, though, we have to split the fraction up. This is going to be cosine squared x over cosine squared x plus sine squared x over cosine squared x. And we could definitely make that a 1. So I've got 1 plus effectively tangent squared x. And you probably don't remember them, but that is secant squared x. The other option, anyone know what the other way is? That requires, yeah. The top is 1. Cosine squared x plus sine squared x equals 1. So that is 1 over cosine squared x. And that's the definition of secant squared x. Now, the 1 plus tangent squared x is a pain in the butt to remember. And be honest, I don't remember it. This is the only one I remember. So if you're gonna memorize a trig function that is like has squares in it, memorize this one because you can derive the other two from it. Option 1 is divide divide by cosine squared. If I do that, I have 1 plus tangent squared x. Oh, maybe I should put this as 1 plus sine squared x over cosine squared x equals 1 over cosine squared x. And that simplifies to 1 plus tangent squared x equals secant squared x. And the other one you can derive with squares by dividing by sine squared x. If you divide by sine squared x, you've got cosine squared x over sine squared x plus 1 equals 1 over sine squared x. And I didn't give myself a lot of room, so I'm going to clean this up here. This is cotangent squared x plus 1 equals cosecant squared x. And that is also the one I probably use the least. Let's take a 5-minute break, let your brains purge a little bit. We still have more to do in this section. Like we just went over like deriving a bunch of this shit, that's all. I guess I could hit pause while I take a break. It's a little hard for people on Zoom unless you guys want me to throw you guys into some breakout rooms. I can throw you guys into some breakout rooms, but I probably won't remember to bring you back. Try working on these and seeing what you come up with. I'll throw down the product rule and quotient rule as a reminder real quick. That looks funny using the prime on the quotient. Because with the 2 down there, the prime looks like a 1. Maybe I need to put it at an angle. Because it is at the prime is at like an angle. Probably off the screen. So working on this for a few minutes. I'm gonna hit pause recording again while you guys work on it. All right, let's go ahead and start working on these together. I realized with these giant markers that I use that writing on these pages isn't gonna give it a lot of room. So I'm gonna just write them up here on another piece of paper. So we've got f of x equals x squared cosine x. This is a product of x squared times cosine x. So we're going to use the product rule. We're going to do x squared prime cosine x plus, this is f prime of x when we do it, plus x squared, and we've got cosine x prime. The derivative of x squared is 2x, and cosine x doesn't change. And then we've got x squared, and the derivative of cosine x is negative sine x. So if I were to clean this up a little bit, I would say 2x cosine x minus x squared sine x. And call that a wrap. You guys get that? I see some nods. Some people are ignoring the shit out of me. Rude. Alright. Let's take a look at g of x. G of x is square root of secant x. I'm sorry, square root of x times secant x plus 3. Now, I think this is a lot easier if I write this as x to the 1/2 times secant x plus 3. When I take g prime of x, we have the derivative of x to the 1/2 secant x plus the derivative of 3. And that one goes to 0. And this is going to require the product rule. So I've got x to the 1/2 prime secant x plus x to the 1/2 and then secant x prime. This, we bring the power down and we lower it by 1. 1/2 minus 1 is negative 1/2. And the derivative of secant x is secant tangent. And since I didn't start with fractional exponents, I'm not going to end with fractional exponents. I'm going to turn this into 1 over 2 root x. Because x to the negative 1/2 is the same thing as 1 over x to the 1/2. And I guess I could put secant x on top. I don't need to like have parentheses there. And here I could just have square root of x, secant x, tangent x. And I would probably leave it there. I don't think getting a common denominator helps with anything. Any questions on that one? All right. And finally, we have h of x. Cosine x over 1 plus sine x. So we got a quotient rule. Quotient rule is high prime low minus high low prime over low squared. So h prime of x is going to be the derivative of the high. So d dx cosine x times the low, 1 plus sine x. And then we have minus high times the derivative of the low, all over low squared. Now, granted, if I were doing this, I would probably skip this line and go next to the next line. I'm just making sure everyone knows where I'm taking the derivative, because who here has actually worked on the 2.4 homework? Show offs. The ladies in here just dropping mics on you fools. They represent
Is that bikes?
Mike,
Oh,
dropping the mic,
I haven't heard.
mic drop.
Yeah.
Cynthia and Voldemort are kicking y'all's asses. That's what I'm seeing. All right, so I would probably jump to the next line where I just took the derivative. And derivative of cosine x is negative sine x. And I've got 1 plus sine x still. And then I've got minus cosine x times the derivative of 1 plus sine x. The 1 goes to a 0 and the sine x goes to cosine x. So this is just another cosine x. All over 1 plus sine x squared. Now I didn't like leaving it there. So I had h prime of x equals negative sine x. It feels like I made a mistake. I made a mistake in my notes. Look at this shit. All right, this is way cleaner than what I got in my notes. I had a positive right here, and that's not right. I got a bad habit of not putting parentheses. This actually cleans up a little bit more. I can factor out of these two. If I factor out of the negative, I have sine squared x plus cosine squared x. And we saw that equals 1. So this should simplify to h prime of x equals negative sine x. We got a minus 1 over 1 plus sine x squared. Look at this. If I factor out the negative, that's 1 plus sine x on top over 1 plus sine x squared on bottom. So h prime of x cleans all the way up to negative 1 over 1 plus sine x. That's crazy. It's like what we started with, but the cosine one, did I make a mistake? Yeah, go ahead.
Before we got to simplify like on a test to get full credit, and we do the first 2 steps. Is that full credit on the test, or you want us to go all the way?
You should try to get it down to, so see if you can reduce it. If you get it down, like I would get to here and stop.
Yeah.
Go through the rest of the test, come back and try, like finish the rest of the test, come back and try to do more. Like going from here to here might be a little bit of the bonus. So the actual calculus work was taking the derivative. So almost all the credit comes from getting to that point. All right, you guys ready for a little bit more? No. Don't shake your head no, you're ready, you just need a little bit more time to write. This is no bullshit. For those of you that like a little bit of application, let's apply this. Assume that a particle's position on the x-axis is given by x equals 3 cosine t plus 4 sine t, where x is measured in feet and t is measured in seconds. Part A is find the particle's position when t equals 0, t equals pi over 2, and t equals pi. So I can see this x is just a function of t. X of t equals 3 cosine t plus 4 sine t. And maybe I should wait to let you guys write down the problem before I actually do some math. Am I recording? Did I hit record? Yes, I did. So we want to find the position. That is the position function. So we're just evaluating for part A, we're just plugging in the t's. X of 0 is 3 cosine 0 plus 4 sine 0. What's cosine 0? And what's sine 0? 0. So this just evaluates the 3. And we have x of pi over 2 equals 3 cosine pi over 2 plus 4 sine pi over 2. What's cosine of pi over 2? What? I heard different answers. What is it? Anybody?
I said square root of 2 over 2.
Oh, that is not it.
He said
0. Square root of 2 over 2 is 45 degrees. Which is pi over 4. Like I heard you say something, but I didn't hear square root of 2 over 2. I heard the 0 over it. What about sine of pi over 2? 1. So this evaluates to 4. And then x of pi. What is cosine of pi? -1. And sine of pi? 0. So this is -3. All right, so that was pretty easy. There was no calculus there, right? That just forced you to remember some trig. Now it says find the particle's velocity. Velocity is a change in position over a change in time. So it's ddt of x. So we're taking the derivative of x with respect to t. X prime of t is, what's the derivative of cosine? Negative sine. I'll put the negative there and put the sign here. What's the derivative of cosine or sine? Cosine. And now we're doing the same thing. Now they want us to evaluate at the same times. So we'll do x prime of 0, x prime of pi over 2, and x prime of pi. And here I got -3 sine pi over 2 plus 4 cosine pi over 2. And here we've got -3 sine pi plus 4 cosine pi. So sine of 0 is 0. And cosine of 0 is 1. So we have 4 there. Negative or sine of pi over 2. 1. We just asked these, so I don't know why I'm asking again. This is -3. And we've got sine of pi was 0. And cosine of pi was -1. So we got -4. When we go to, when you get to calculus 3, we start looking at this in 3 dimensions. And this makes like the flight of like a butterfly going up in a circle. It makes a helix shape. So this in 3 dimensions, if we do have a t as the height, it makes a helix shape as it's going up, which is kind of neat. Little DNA sequence. All right, now they want us to find y with a 4 like that if y equals -2 sine x. Which means they want us to find the 4th derivative. So we are going to start with y equals -2 sine x. What is dy dx? -2 cosine x. What is, I'm going to get used to you guys seeing multiple notations here. D squared y over dx squared. This is the 2nd derivative. This is like going from here to here is like doing the derivative again.
2 sine x.
Yeah, cosine becomes negative, so it's going to switch to a positive. We're going to have 2 sine x. Now, if we take the derivative again with respect to x, d dx, we are going to get d cubed y over dx cubed. Get you guys some notation. They come in all different ways. Might as well get used to them now. Derivative here is 2 cosine x. And finally, we take the derivative of that with respect to x. D dx here gets us d to the 4th y over dx to the 4th, which is our y4 like that. What is this value?
Sine x.
-2 sine x, which is it's the original equation. Why? The 4th derivative of a trig function is the original. So the derivatives of sine and cosine are cyclical. They go in cycles. Kind of like I to a power, the imaginary I, it has a cycle of 4. The derivatives of sine and cosine have a cycle of 4. That's kind of neat, I think. Any questions? We're going to start 2.6 for a second, at least get the definition down. Does anyone need it up longer before I start yanking shit? All right. 2.6 is on the great and blessed chain rule. If f of u is differentiable, that's got a fucking typo in it. There's no E right there. If f of u is differentiable at the point u equals f of x, and g of x is differentiable at x, then the composite function of f of g of x is differentiable at x. This looks funny. That should say u equals g of x. That's a typo. Because we're doing f of g of x inside of f. So if f of g of x is differential at x, we have, you start with f of g of x. And when you take the derivative, you work inward. So we're going to do the derivative of f first. And we're going to leave g of x inside of it alone. And then we move inward again and we take the derivative of g prime of x. So you can actually picture this like a box with another box inside. And this box represents f of x and this box represents g of x. And as we take the derivative, we're moving inside. d dx, I take the derivative, I'm just affecting f of x. And then I got to do the derivative again, and it's hitting g of x. So d dx is my arrow here. And this can have as many boxes inside of boxes as everything else. My cousin tormented my mom at fucking one Christmas. He bought her some very, very nice jewelry. I want to say it was like diamond earrings or something like that. But you know how small a diamond earrings box is. He put it in a box, he wrapped that shit up with fucking like packaging tape or fucking duct tape or some shit like that. Put it in another box, wrap that up in layers of duct tape or packaging tape. He ended up having it in like a microwave sized box. Fucking like, and she had to go through box after box after box with so much tape she needed a knife to cut the fucking thing open. It was great. Took her forever. It's kind of like that. You keep going inside another box. The way, this is Newton's notation with the F prime. This is Newton. Newton liked the primes. Leibniz did the dy dx. So that is another way of looking at it. Dy dx equals dy du times du dx. Which is like saying y prime of u times u prime of x. But I don't know that it's helpful. This could be a pain in the ass to take the derivative of, right? Using our normal rules. We would have to multiply this out. It could speed it up with Pascal's triangle and doing binomial expansion. But we've got an exponent of 9 here. This would be a bitch. This is like, we can speed this up a little bit by recognizing that we've got a function raised to a power. If I call u 4 minus 3x, I really have y equals u to the 9th. This is the Leibniz approach. Which might be the easiest one for you guys to pick up. So if I want to do the Leibniz approach right here, let's bring it down here. dy du is what? Someone wave their hands.
The 9x to the power of 8.
9, not x, but 9u to the 8. Why is it not kicking on? Someone in the front try to wave their hand. What the fuck? Power outage. Nope, not a power outage because we're still on Zoom and shit. What is du dx? Well, I have u right here. -3. So I'm gonna do it both ways. If we use Leibniz notation, dy dx equals dy du dx. What we have is 9u to the 8th times -3, which would be -27u to the 8th. But we didn't start with u, so we don't want to end with u. We're going to replace u with what we started with, 4 minus 3x. This way makes it's like easy to do where you do it in pieces and put them together. It's pretty easy approach. The other way of doing it, maybe I should give you guys a second to write that shit, finish writing it.
How did we get du dx equals -3?
We took ddx of this. So the derivative of 4 is 0. Derivative of -3x is -3. So, are you good? Does it make sense?
Yeah.
It's just like having a u instead of a y. All right, the other way of going about it is we started with 4 minus 3x to the 9th. If you have them in parentheses, everything nested well in parentheses, you just start on the outside of the parentheses and work in. So I'm going to work in. I'm starting on the outside, the 9. I'm going to address the 9. We'll deal with the 9. So the 9 comes down, and I have the 4 minus 3x. That still stays to the 8th power. And now I'm going to do the derivative right here. And I've got -3. And you get to -27, 4 minus 3x to the 8th. In the box version, maybe I should call that f of g of x outside. The outer box is like doing the derivative of, I think u to the 9th is the best way to show it, which is 4 minus 3x to the 9th. And then we go inside the box. All we have left here is the 4 minus 3x that we're taking the derivative of. So you do the derivative of this one, and then you do the derivative of that one. And that is an 8. That's it for today. A whole 5 minutes early. Go me! We are gonna finish up 2.6 on, let's talk about next week real quick. 2.6 will be Tuesday. I am gonna try to squeeze in 1.4, but 1.4 you are not getting tested on. 1.4 is the FML section, really is. I hated it as a student. I didn't like it as a grad student. Still don't like it. It's how to prove like some stuff, but you need to have seen it before you leave like calculus. On Thursday, we will go over a practice exam. And not next Tuesday, but the following Tuesday. Dun, dun, dun. The bell will be tolling. Have a good day, guys.